All right, so we are on to lesson 2 for today. So we're looking at a function notation. Relatively easy, probably should have been done as one of our first lessons, but you live and you learn. So a function is a relation in which every x, that's not the text. Every x value has only one y. Okay, so that means that if we were to look vertically like this, there's ever only going to be one point on that graph. Okay, so we're going like this. Same with this, there's only one point as we're looking down the graph like that. Okay, only one point. And that's what a function is. Let's say, for example, that our graph was like this, for example. That wouldn't be a function because there'd be a point right there and there would be a point right there. So that means that there is more than one y for each x. So there would be a point, there would be a point. So that wouldn't be a function. You could only have one point. And what I just did is called the vertical line test. So you literally just go vertically on your graph and see if there's more than one point on that graph. Okay, so they all pass the vertical line test. So I'm going to erase this. We're going to keep moving forward. Are there other ways to represent functions? So functions can also be represented with what we call a function notation. You guys would have seen it, notation, or f of x. So I kind of brushed it off a little bit. If you haven't seen it before, it looks like f of x. So it's the same thing as y, it just means the function of x. Okay. So we write it as f of x or f at x. So why do we use function notation? Function notation is a concise way to give instructions about operations to be performed with functions. Honest to God, it's the exact same thing as a y. There's not too much difference. So I'm going to clear that. We're going to do a few examples. Okay, so for example, f3 means evaluate the function when x is equal to 3. So it just tells us when we should set x to a number, in other words. So if f of x equals 2x plus 1, what is f of 3? So that just means, in other words, that we're putting our x equal to 3 in our equations. Okay, so we're going to go to our equation where there's an x. We do state it as f of 3 is equal to 2 times 3 plus 1. So 2 times 3 is 6 plus 1 is 7. Same thing here. So we're going to set our x to 0. So f of 0 is equal to 2 times 0 plus 1, which is 0 plus 1, which is 1. Here we're going to set our x equal to -1. So f of -1 is 2 times -1 plus 1. -2 plus 1, so it's -1. Okay, we're going to do, there's quite a few examples actually. So I'm going to clear this. Okay, and we've seen that x is the domain or input value, f of x is the range or the output value. We graph ordered pairs, which can be written in the form of x f of x, which is the same thing as x y. It doesn't always have to be f. So in this case, we're using g of x. It means the same thing. They're just using different letters. So we're going to do the same thing here. So our x is going to be equal to -3 and our function here. So -3 squared minus 4 times -3, which is equal to 9 plus 12, which is 21. Okay, and we're going to put it in an ordered pair just so we get some practice. So our x value in that was -3 and our y value was 21. When we have something like this, I'm going to do it in 2 different colors so it's a bit easier. So this guy is going to be when x is equal to 2. So we're going to go into our function. It'll be 2 squared minus 4 times 2. And then I'm going to use a different color. We're going to do minus, and we're going to do in brackets. We're going to do the exact same function, but with the 1. So it'll be 1 squared minus 4 times 1. Okay, so 2 squared is 4 minus 4 times 2 is 8. We're going to go back to our green. Make sure that it stays in bracket because of this negative. It's going to impact that a bit. Okay, so this is -4. So as you can see, this is the same function. So we did it once, and then we did it a second time with 2 different values. I hope that makes sense. Okay, and then minus -3. So this will give us in total -1. Okay. If we look at this one, so this will be the same thing as g of 1. So we're just going to do the exact same thing. So 1 squared minus 4 times 1. 1 minus 4, and it'll be -3. So if we put it in an ordered pair, that would be 1, -3. If we look at this one, so this means that it's going to be 2 times the answer of this. So our first thing that we're going to do is our g minus 5. So we're going to have -5 squared minus 4, -5, which gives us 25 plus 20, which gives us 45. Okay, and then we're going to times that by 2. So 2g of -5 is equal to 2 times 45, which is 90. So I'm going to erase this. We're going to move forward. Okay, our original equation, I'm going to write it on the side here just so I don't forget. So it's x squared minus 4x. So we're going to do the same thing here as we just did. So we're going to do g of 10 and then divide that answer by 5. So g of 10 is equal to 10 squared minus 4 times 10, which is 100 minus 40, which is 60. Okay, and then g of 10 divided by 5 is going to be equal to 60 divided by 5, which gives us 12. Okay. We have example 3 here. So if h of x is equal to 4x minus 3, solve h of x equals 30 or 41, sorry. So this is going to be the same thing. You can think of it as y equals 4x minus 3, solve x equals 41. So you're trying to find what x is. It's the exact same thing. They just make it a little bit more different. So we're going to set our y as 41, put our equation, and we're going to solve for x. So we're going to add 3 on both sides. So it's 44 is equal to 4x. Divide 4 on both sides. So our x is equal to 11. We're going to look at how to find these on a graph real quick, and then you guys are done. You have independent questions, and that's it. So clearing this. So using the graph below, solve the following. So I'm going to make this a bit smaller. That way we can do it at the same time. Quite literally, you're going to look at the graph. So where is x of 1? X of 1 is here. What's our y value? It's 1. That's it. So our x is -2, whereas our y is 0. 2, our y is at 4. For this guy, we're going to do the same thing that we had done before. So it's negative here. So -4 is at -2 minus the answer where it is -3, which is -1. So it gives us -1. Okay, same here. So 2 times our answer at -3, which is -1, plus 3 times our answer where it's at 1, so 3. So we have -2 plus 9, which is 7.